Welcome to the world of dimensions. We will look at the fourth dimension. To understand the fourth dimension, you'll need to know about the first, second, and third dimensions. Here's a brief overview of the first three dimensions. There is one axis in the first dimension, and so only one coordinate is needed to specify a point. There are two axes in the second dimension, and so two coordinates needed. And with three axes, three coordinates are required in the third dimension. With this information, we can guess the fourth dimension has four axes, and so one will need four coordinates to specify a point in the 4D world. Where does the fourth axis point to? Many say it is time, so 4D organisms will be able to travel in time or anti-time. You have to think of time as a direction which 4D organisms can walk towards. Because no one has been to the fourth dimension, we will use a dimensional analogy to understand the fourth dimension. An easy way to explain the dimensional analogy is an example of a higher dimensional factor in the lower dimensions, and vice versa. A cube is the dimensional analogy of the square. Likewise, the tesseract is the dimensional analogy of the 3D cube. This is the tesseract. To understand why the tesseract looks as it is from our point of view, let's use a dimensional analogy and see how a cube will look like to someone in a 2D world. Tom lives in the second dimension. A cube will be drawn or projected on the 2D world for Tom to see. Assume the lines are made of special material that is transparent, so Tom can see through them. The blue and red squares are identical, but look different, because they're distorted in 2D space. The green trapezoids are also identical to the other quadrilaterals, but distorted in shape. The blue and red squares share the same 2D coordinates, but has a different 3D coordinate to each other. The other squares are between the two squares, tilted in the third dimension. If the cube rotates in the third dimension, it will appear like this to Tom. Notice how the squares seem to go through each other. The cubes and the circle show what happened in the 3D world. This will be impossible to happen on a 2D square, but it's completely natural for cubes. The cube could have rotated in the 2D direction. Then, for Tom, it will look just like a square rotating in his world. With the relationship of the cube and the 2D world in mind, look at the tesseract again. Notice that there are 8 3D blocks in the tesseract, one in the center, one in the outer, and 6 between them. All of the blocks are actually perfect cubes, and the same size, but it seems different because it is distorted in the 3D space, similar to how a cube is distorted in 2D space. Also, the cube at the center is not actually in the center, it only seems to be so. All the cubes are linked in 4D space, similar to how cubes are linked up to make a cube in 3D space. You might ask, the tesseract looks as if it's a 3D shape, isn't it one? The answer is no. Can you connect 8 cubes in a way so all the cube spaces are touching another cube's face? Of course you can't, but this is how it is with the tesseract. Remember, the cubes, that are distorted in our 3D world, are all equal in shape and size. The center and outer cubes share the same 3D coordinates. The only difference is that they are in different 4D directions. The other cubes are also on the same 3D position, except that they are tilted in the 4D direction. Let's look at the nets of these shapes before we continue. This is a net of a cube. When folded up, it makes a cube. This is a net of a tesseract. Compare the tesseract to its net. Can you see how the cubes fold into the fourth dimension to make the tesseract? The third dimension can be thought of as lots of 2D spaces stacked in the third dimension. Like so, the fourth dimension is formed with lots of 3D dimensional spaces stacked in the fourth dimension. So if we were to travel in the fourth dimension, we will see lots of different 3D worlds. Let's assume that Tom's 2D world is in a 3D cube, and a different 2D world that Bob lives in is on the same cube. Both of these worlds are on the exact same 2D coordinates. But since they have different 3D coordinates, Tom doesn't know that Bob's world exists, and the same for Bob. If Tom somehow moves into the third dimension and goes into Bob's world, Tom's Z coordinate will change, and he will be in a different 2D world. Does that mean Tom became 3-dimensional? No, he is still 2D. While Tom is moving towards Bob's world, he will see 2D sections of the cube, but only one section at a time. Tom still perceives the surrounding as a 2D world, so he can't see the third dimensional direction, which is the direction he's moving towards.